Number 7, interlock. There are safety features in our electrical circuits that enable our equipment to run in specific conditions. For example, we have conveyor number 1 and conveyor number 2. The way the interlock works is this conveyor number 2 has to start, then conveyor number 1 starts. If the conveyor belt number 2 stops, then it will mean that conveyor number 1 also will stop so that it doesn't send material to conveyor number 1. Then isolation. Electrical isolation is the separating of contacts between the high potential voltage or high potential electricity to lower potential electricity. Then we have lock-off. Lock-off is to put a padlock so that the people who are working on that equipment are safe to work on it. Then we have a danger sign. A danger sign is something that we put to warn people about the potential hazards so that people cannot switch on the power to prevent accidents. Power restoration is the opposite of isolation. Power restoration is to put back or to flip back the circuit or the contacts so that we allow again the flow of electricity. Remember, we said that isolation is to separate the contacts, but when we say power restoration is to allow now again the power to flow, electricity to flow. Then the dielectric strength. Any wire carrying conductor has some magnetic fields around it. So those magnetic fields, they can cause an accident if they meet together. We have 3 phases. It is the ability of a material to withstand the electrical fields. Then conveyor belt. Conveyor belt is like a load for material flow. So we have short conveyor belts in our department and long conveyor belts in our department. There are power surge, number 14. Power surge is the rise and at the same time it can mean the decline in voltage, which can damage equipment. Permit number 15 is the official approval to do something. Then power factor. Power factor is very important for any industry like this one. It's the one that a company like this one should look into, because when you have a poor power factor, it will mean that you'll be drawing too much current from the supply authority and you lose a lot of money. Then we have programmable logic control. Our plant is fully automated. We use PLC, where maybe one person is just in the control room, is able to control equipment in the plant. Number 18, variable speed drive. Variable speed drives are speed control devices that we apply in our department. Maybe where we want to take, we need to control the vessel where that material is going to. Then earth leakage. This is very dangerous in equipment. Earth leakage can kill a person if not handled properly. It is that current that leaks to metal casings that can damage the equipment and also kill a person. Then we have vacuum circuit breaker. Breakers are named after their quenching medium, the breaker that we use for high voltage. When we receive material from underground, the material reaches on the stockpile. Under the stockpile, we have 3 vibrator motors that discharge material on the conveyor belt number 1, then it goes to conveyor belt number 2, then to our bins. From the secondary bins, we draw that material into our crushers. So the motors that we use in our crushers are induction, squirrel cage induction motors. So we have 2 secondary crushers in our department. Then we have 3 tertiary crushers. The capacity of secondary crushers are 1485, which is a 4-pole motor. The tertiary crushers, the capacity is 220 kilowatts. So we do preventive maintenance. The kind of maintenance that we do, we increase the grease in our motors. We also remove dust from these motors. We also tighten connections in our motors. As you can see, that is the motor, and this is our crusher. Okay? And this is our control system. I said that we have a stockpile there and the 3 motors. We have the conveyor belt number 1, conveyor belt number 2, then goes into the tertiary bins. And here we have these crushers. These are the secondary crushers, and we have the tertiary crushers for our process. Then conveyor belts The conveyor belts that we have, the capacity of the motors that we have, the motors look like the one that we've just seen. The conveyor belts, the capacity is 110 kilowatt. The speed is 1485. Also, we have short conveyor belt. Long conveyor belt move material from one place to another at a long distance. This is how our conveyor belt looks like. The power transformers, these are static machines that transform energy, voltages from higher level to lower values. We have control transformers. We have even small transformers, like in our plant. We receive 11 kV from CEC via chamber metals, voltage from 11 kV to 550. At the same time, within our plant, we have 380 steps down to 220. Again, we have also power control transformers, which are 550 or 110 for our control systems. So maintenance done on our transformers, we look at oil level, we look at the cooling system, oil analysis, grounding, earthing. This earthing is very important because it prevents someone from getting electrocuted. Then we have relays. We have these relays also, very, very important because when there is pressure in the transformer, it can even trip the transformer so that the transformer doesn't get damaged. You can see my men, we have qualified manpower to do these jobs. So as you can see from there, we were changing the oil transformers. Then we have vacuum circuit breakers. These vacuum circuit breakers are the switches. They are the ones that switch on the transformer and switch off the transformer. This is an electrical switch that safely interrupts fault currents like short circuit. I'm glad that I joined NFC in 2000. In my section concentrator, we haven't recorded any person dying. We've been working very safely, not even burning someone with electricity from 2000 up to date. These are the maintenance that we do. We have mechanical maintenance, where we physically check the leakages, the cracks on the breaker itself. On the electrical side also, we also check the insulation between the phases because phases do not meet. We also check the contacts, and we also look at the closing contacts and the tripping contact. Tripping contact is very important because if there is a problem, our circuit breaker should quickly trip so that it protects the person who is working on the equipment and also protect the equipment. Then we have control circuit. In a control circuit, we also test the relays and the interlock. You can see our able men are busy doing maintenance on the high voltage circuit breaker, which is the vacuum circuit breaker we have seen there. And we have a synchronous motor. Synchronous motor, this is the biggest motor in our department. It was installed in 2000. Up to now, we have no problem because of the good maintenance that we do on this. We have only two ball mills, ball mill number 1 and ball mill number 2. We look at the characteristics. That motor has a constant speed. Then we have power factor correction. I give you an example of this one. The plant works like this. This is the power factor, which is the cosine theta. Then this one is the power that we get from the supply, and this one is the true power that we use. Now here we have the wasted power that we get from the plant. It means that this is the wasted power. So it reduces this wasted power to maybe somewhere there so that we don't pay a lot of money to the supply authority like CEC. It is able to correct that. On this side, this is our motor. We've been opening and closing this motor, doing maintenance, because in our department, it is a dust area. There is too much dust that accumulates in the winding, and this is what we call the oil chamber. There is a very expensive bearing there, so we put the collect oil, not transformer oil, but hydraulic oil, which is HLP 100. We have inverter in our department. These are variable speed drives. These variable speed drives, I talked about it in our keywords. They control the speed of our motor. We don't want overflow on the cyclones. The person who is in the control room is able to control the speed going to that. When we increase the frequency, also we increase the speed. So these are direct proportion, as you can see. If we increase this one, we also increase this one. When we reduce this one, we also reduce this one, because the number of poles are fixed, and this is a constant. That is the equipment. Our challenges when the mouse comes into contact with the live part. So maintenance is done weekly, monthly, and sometimes after 1 year. So ventilation is very important because these are electronic devices. In the substation, we found switch gears, and we also found things like the fire extinguisher there, the one that I can see from there. There is also the phones to alert other people if there is an accident. This is done by our electricians. This is how it looks like, very neat. We installed in 2000, but the substation looks okay. Then communication. Communication is very important in our department, and I think everywhere communication is important. What is communication? Communication is the transfer of information from one person to another, or from one group of people to another, or from one company to another. That should end into a desirable feedback. Communication, there must be an interaction. So you ask me questions, I ask you questions. This communication is very important because we are coming from different backgrounds. We are coming from different cultures. This idea which the CEO brought to us is very important because it is trying to improve our communication, because we are in strategic positions where we must be able to communicate effectively to our subordinates. And when we are communicating, we should use the language that our subordinates are going to understand, or the group that we are communicating to are able to understand. How can we improve communication? We can improve communication by planning what to communicate, and also use more than one communication method. When I'm communicating with my boss, Mr. Ma, or Mr. Den, or Mr. Shaw, sometimes when I use the words, if he doesn't understand it, I write, and sometimes we get the drawing so that we understand each other. This is our last topic, which is part of our discussion, electrical isolation. Very important. We said the electrical isolation is separating of contacts. Like I said, in our department, no one has died out of electricity. In our department, we follow safety. We comply to safety, because if you kill a person in Zambia, it's a very big offense. You can be even jailed. You can go to prison. This isolation lock-off, whenever we are doing our jobs, we have to isolate. And for us to isolate, we just don't go and switch off the switch and go. No. First of all, we get permission from the operator or from the shift foreman. When we get permission that we are going to isolate that one, the fitter comes to isolate. He's going to come with the lock and the key. He's going to put the multi-caliper there. The multi-caliper looks like this one, so that no one is going to switch on while maintenance is going on in the plant. It is going to be accompanied by a danger sign. This is the danger sign. You can see here, there is my name there, there is my number and the phone number there. So when work is complete, there is what we call power restoration. That is to put back power so that electricity can flow again. But what is going to happen? The person who isolated that equipment is going to clear his men and move and clear the tools. After clearing the tools, he's going to come to the person that gave him that permit to work on that equipment. Then they are going to call an electrician. That person will go with an electrician into the substation, remove the lock. Then that's when they can go with the operator in the plant to that equipment. Now, if during this period, the multi-caliper that I showed you there, it is not only one person who should put the lock there. There must be several people. If there are many people who are working on it, say for example, the fitters are working there, they have to put the lock there. If the boiler maker also wants to work there, they're going to put the lock there. Maybe production people also want to clear the conveyor belt or the motor, whatever, they are going to put there. Then this is what we don't want in our plant. And this is what has made us to work without accidents in our department. Works carried out first without isolation. We make sure that when we are working, the unity is isolated. Using start-stop button to guide the switch. No, we don't do that. Because if I'm to isolate, if I'm to work on this light, I'm not just going to switch off from there where the switch is. No, I have to go to where the breakers are so that I put the lock there, because on the switch we don't have where to lock. So this is forbidden. It's not allowed. Removing unit fuses. Some equipment have fuses. We don't just remove the fuses. These fuses, maybe other people can come and put the fuses and start the equipment. So when we isolate, we must make sure that the fuses are taken away and the equipment is locked. Using conveyor belt, emergency stop wire. That wire I showed you, that is very important. Maybe some people say, no, since the boss is not there, let us just use this conveyor belt to do that. That is forbidden. We have to make sure that it is locked because you cannot lock on the pull wire. Or pressing a person to guide the switch. Lastly, it is the responsibility of the operator there in our various departments. It's the responsibility of the operator and the responsibility of the general foreman, the responsibility of the superintendent to ensure that the machines work effectively. If there is unsafe methods that we are trying to employ there, that person responsible should stop us. So in our department, we always comply to the safety standards in our plant. I think this is what I had for you. We've come to the end of our presentation.